We're going to go ahead and practice graphing polynomial functions. The first couple I have in factored form already, so we will go ahead and look at those. So we have y equals 2x minus 1 times x plus 3 times x plus 1 squared. Since it's factored already, we can find our zeros. So the zeros are going to be when these factors equal 0. So we want to find out when 2x minus 1 equals 0. We did find a quick way to do that, but we'll go ahead and solve it. We would add 1 to both sides. So we have 2x equals 1, and then divide both sides by 2. We get x equals a half. That's one of our zeros. And so that is one of our x-intercepts. So a 0 is an x-intercept. What value of x makes this equal 0? Well, that's negative 3. So we have a 0 at negative 3. And what makes this equal 0? That's x equals negative 1. But it has a squared, though, so that's multiplicity 2. Which means it will change directions there at negative 1. Next, we can look at our tails, or the end behavior. And to look at the tails, we have to look at, we normally look at the leading coefficient. Well, this is already factored, so we don't have our leading coefficient written there. But if we think through this, we would, to multiply this out, we would multiply those, and we would have, when we multiply these two, we would have a 2x squared. That would be our highest term. If we multiplied this out, because this is a x plus 1 squared, we would have x plus 1 times x plus 1, and we would have an x squared there, but then we would multiply the x squared here by an x squared here, and we would have an x to the 4th. So our degree would be 4. Another way we can do that is we can count x, 1, 2, and then this is going to be 3, 4 because it's squared. And then it will be positive. So actually the leading coefficient would be 2x to the 4th. And so that is an even degree, and it's positive. So both tails would go up. So even and positive. So both tails up. Symmetry. It's tough to look at symmetry here because it's not that multiplied out, so we can't really look at symmetry or discuss symmetry right now. And then what we want to do is find some points, including the y-intercept. The y-intercept comes from really when we multiply all of our constants. So you just have to be careful when there's a square. This is a 1 times 1, so 1 times 3 times negative 1 is negative 3. So the y-intercept will be negative 3. So that would be down here. And then maybe we should plug in negative 2 to help us find what happens between negative 3 and negative 1. So plugging in negative 2, we're going to go ahead and put that into our function here. So let's think through this as we go through. 2 times negative 2 is negative 4. Minus 1 is negative 5. So we have negative 5 times negative 2 plus 3 is 1. And then negative 2 plus 1 is negative 1. But that is squared. So when we plug in negative 2, multiplying this out, we get negative 5. So we have negative 2, negative 5. So put a point there at negative 2, negative 5. Now that we have a few points there, we can go ahead and sketch the graph of our function. We'll start up above here. It's going to pass through negative 3. It has to hit negative 5 here. When we come up to negative 1, remember that was multiplicity 2, so it comes there and then kind of reflects off or comes off. It has to hit the y-intercept, and then it will go up through a half and then continue upward like that. My other tail was in the, didn't get that, so we'll just erase that. And so there is a sketch of that first graph. Next one, we see this f of x function. It's already factored, so we can go ahead and figure out what our zeros are, which, remember, the zeros are the x-intercepts. We'll consider multiplicity. Well, this one, just having an x out here, what makes that equal 0? Well, that is just 0. So we have an x out there by itself. We know one of our zeros is 0. 3, a 0 of -3, 5, and -1. So we'll go ahead and graph those. So we have 0, 3, and -3. 5 and -1. These are all multiplicity 1. That means they're all to the first power. So they're all odd. So our graph will just pass through each of those. So those are the zeros. Next, we'll look at our tails, or the end behavior. And end behavior, we would look at the leading coefficient. Well, notice we would have basically an x times an x times an x times an x times an x. That is x to the 5th. So, and it's positive. X to the 5th. So this is odd and positive, which means this is going to be in opposite directions. The left will be down, and the right will go up. So we're going to put a couple arrows in there, left down and right up. We don't have this multiplied out, so we can't discuss the symmetry right now. There's not going to be any symmetry, but here we go. Not in a special symmetry. Next, we're going to look at some points. So it looks like maybe, well, we see the y-intercept already is 0, so we don't have to discuss that. So let's go ahead and find -2, maybe either 1 or 2 here. We could do both if we wanted, and 4. Also, if we wanted to, we could do -½ We don't have to. We're just kind of getting an idea of what's going on here. So let's go ahead and find these extra points to help us graph this. So we're going to plug in some x values, and we'll do -2. Let's go ahead and do -½ We'll do 1 and 2. That's fine. It will take us a little extra time, but no big deal. We're in no rush. And so we're going to plug these. So we'll take each of those numbers and we'll plug them into this equation right here. So we'll work our way across. So plugging in -2, we have -2 in for x, and then -2 minus 3 is -5. -2 plus 3 is 1. -2 minus 5 is -7. And -2 plus 1 is -1. So I just put -2 in for x there and worked through solving that. So this is going to be 10 times 7, which is 70. Now put in 1/2, so -1/2, sorry, -1/2. -1/2 minus 3 is -3.5, or -7/2. Putting -½ in here, that's 2.5, which is 5/2. Putting 1/2 into the next part is -4.5, so -9/2. And -½ plus 1 is 1/2. All right, we have 3 negatives here, which is going to make our answer negative. And then we have in the numerator, 7 times 5 is 35, and then 35 times 9, I'll just write that up here, 35 times 9 is 5, add the 4, 9 times 3 is 27, 31, so 315. Divided by, we have, in the denominator, we have 2 to the 5th, which is 32. Well, that is approximately -10. Not quite, but close enough for our purposes. Plugging in 1. So 1 minus 3 is -2. 1 plus 3 is 4. 1 minus 5 is -4. And 1 plus 1 is 2. That's 2 negatives, so it's going to be positive, and then multiplying that out, we have 64. Plugging in 2. 2 minus 3 is -1. 2 plus 3 is 5. 2 minus 5 is -3. And 2 plus 1 is 3. So multiplying that out, we get positive 90. And then plugging in 4. Plugging in 4, we have 4. 4 minus 3 is 1. 4 plus 3 is 7. 4 minus 5 is -1. And 4 plus 1 is 5. So that ends up being -140. All right, so this graph right here, we are not going to count these as ones. Obviously, you see that we have some very large numbers here. So we have to get down to -140. So maybe if we count by 20s, that would work. So we're going to count by 20s. So this, when we graph this, realize this is not what it looked like if it was a 1-to-1 scale for the x and y axis. So -10, -20. Nope, that's not what we want. We're counting by 20s. So -20, -40. I'm going to go ahead and graph some of those extra points on there. So -2, we were up at 70. So that's there. At -1/2, we were at -10. At 1, we were at 64. And then at 2, we were at 90. And then at 4, we are at -140. And so we're going to graph, and we're going to hit each of those points. When we graph polynomials, realize we are just doing a sketch, so it's not exact, but we have our zeros in the right place, and we have a rough idea of where this graph is. So we're going through each of our zeros, hitting each of these other points that we graphed, and then there is the graph of that function. Just noting and remembering that this scale is a lot different than the x scale. So the x scale, we were counting by ones. Oops, that's -3. So there's the graph of that function. Our next few I do not have in factored form, so we're going to have to factor these. As we come across these, we're going to have a few different variations, and we don't always have to use the rational root theorem. We don't always have to use C over D. So in this case, I'm noticing that I have a 3 and a 2, and if I factor out a 6, in fact, a -6, I'll have a 3 and a 2 there. So we're going to be able to use factoring by grouping. And that just sometimes just takes in recognizing that. When we factor by grouping, if there's a negative here, we want to change that to plus a negative, because when we group, that negative needs to stay with the 18, and we do not want a negative outside the parentheses. So we had to change that to plus a negative. Our first group here, we can factor out an x squared, and we're left with 3x plus 2. In our second group, we can factor out a negative 6, and we're left with 3x plus 2. And you see we have those 3x plus 2's there. We're going to factor out a 3x plus 2. And we notice we have common factors. We can go ahead and factor that out. And so this is 3x plus 2. And we have x squared minus 6. Factoring by grouping doesn't always work, but when it does, it's usually a little quicker than using the rational root theorem, which is finding C over D, possibilities of C over D. So we want to set these equal to 0. And we want to solve both of these. We learned from this earlier. I taught you that we can take the opposite of the constant, which is negative 2. So x equals negative 2 over this number. If you don't understand that, just solve 3x plus 2, and you'll get that answer, and you might see why you get that answer. And then this other one, we're going to put x squared minus 6 equals 0. We add 6 to both sides and then take the square root. And so we get x equals plus or minus the square root of 6. The square root of 6 is somewhere between 2 and 3. So we're going to say that's about, let's say that's about 2.3-ish. I could use a calculator. Maybe 2.4. So we'll say that's about 2.4. And that's plus or minus. And so we're going to graph those zeros. We have negative 2/3. So negative 2/3, we're going to go right here. And we have 2.4 and, or negative 2.4 and positive 2.4. Those are the zeros. They're all multiplicity 1, so the graph will cross through the x-axis at those spots. We have our tails, or the end behavior. We look at our leading coefficient. It's odd degree and positive. So left is going to be down, and right is going to be up. So left down and right up, we'll go ahead and put that in there. There's no symmetry. Symmetry, we look at the degree of each term. If they were all odd or all even, we could talk about symmetry, a special symmetry they have, but they are not all odd and or all even. So no special symmetry there. And then we want some points. First of all, the y-intercept is the constant, which is negative 12. So we're not going to graph that yet, because so negative 12, if we counted by ones, wouldn't fit our graph. So maybe we'll have to count by 2's or 4's or something. Let's see what else we have here. So some other points to check. Let's go ahead and check, maybe 1.5, negative 1.5, I guess. Negative 1.5. And let's try 1. And that should be enough to help us out. We do have the y-intercept already. So negative 1/2. It's not going to be... So we're going to do 3 times negative 1/2, negative 1/2 cubed, plus 2 times negative 1.5 squared, minus 18 times negative 1.5 minus 12. 0.375. And then we're going to try 1. We'll put 1 in there. That's a little easier. 3 times 1 cubed, which is 3. 1 squared is 1, so times 2, minus 18, and minus 12. So that's 5 and negative 30, so negative 25. So we need to get to at least negative 25. So I guess we'll count by 5s. Negative 5, negative 10, negative 15, negative 20, negative 25. 5, 10, 15, 20, 25. And we can go ahead and sketch our graph, although this point right here was 0.375. I'm still a little bit struggling with that one, but I guess it's right. So we go up. Something happens here, but it comes back down. The y-intercept was negative 12. So we're counting by 5s here. So there's the y-intercept. And at 1, it was at negative 25. Has to go through the zeros and has to go up. So there is the graph of g of x. All right, this next one, once again, we have to factor. So it looks like there's an x in common. So if you don't have a constant term, that means you can factor out an x. So we'll go ahead and factor out an x. That leaves us with x to the 4th plus x cubed minus 31x squared minus x plus 30. So we factored out an x. Now let's go ahead and use synthetic division with the rational root theorem. So c, factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. D, leading coefficient is just 1. So c over d is just whatever c is equal to. So that's c over d. So we're going to start with synthetic division and hopefully try to find a couple of these. So we list our coefficients: 1, 1, negative 31, negative 1, and 30. And let's start with 1. Bring down the 1. I'm not going to necessarily talk through all these. I'll just write. All right, first try. So I'm going to erase that. And we'll, now, so we got a remainder of 0. So now we can take this new polynomial, which we had an x to the 4th power. We divided, now we're x cubed. We don't need to write that, but just reminding us. So we got 1, 2, negative 29, and negative 30. We really still have the same c over d values. So we can try again. We could try 1 again, because if it worked here, it still could work again. We know if it didn't work on the first one, it wouldn't work on the second one. Well, that's not even close. If it's not close, you could skip a couple numbers if you wanted to. Let's try 3. Is negative 82, so we're even further away. Also remember that these are actually going to be points on the graph. So this is helping us, at least for graphing it later. They're not useless points. Let's try 5. All right, that worked. So 5 worked. So we have a 0 of 0. So one of the zeros is 0. 1, 5, and now we are left with a quadratic because we were at a 4th power. This was a 4th power cubed. Now we're down to a squared. So this is x squared plus 7x plus 6. We can factor this into x plus 1 and x plus 6. So our other zeros are -1 and -6. Let's go and graph these points. We have 0, 1, 5, -1, and -6. All right, our tails, or our end behavior. This is odd and positive. We've had that several times. So odd and positive, which means the left will go down and the right will go up. So left down, we're running into our work here, left down and right up. Some other values, we already have our y-intercept. We actually have, I need to make a correction. This was from this polynomial, not from our original. So these are not necessarily points on our graph. So we need to plug in some values. Let's go ahead and try -4. That's -3, actually, -3 and 3. We'll put in those. Now, we can plug in, but remember, we also can do synthetic division. So let's do synthetic. I think that might go a little quicker. So we have 1, 1, -31, -1, 30, and we do have to put 0 out here because there is a constant of 0. So we're going to try -3. So bring down the 1. 1 times -3 is -3 plus 1 is -2. This will be -37. Well, we're getting up there already. So 111, positive 111 minus 1 is 110. So -330 plus 30. -330 plus 30 is -300. Oh, and then 900. All right. So at -3, we're at 900. We're at 900. So we're just going to put that up here. -3, 900. So our vertical placement, we're not going to be real accurate here with our y-axis. So plugging in 3. Put in 3. Bring down a 1. Three times 58. 174, so that's -174, -144, because we're adding 30. And 144, 144 times 2 is 188, and then another 144, 432, -432. So -432 down here somewhere, that's 3, -432. So we're going to sketch this graph, and this, it's going to go through all these points because they're all multiplicity 1. They were all odd. an odd number factor. So there's a sketch of our graph. Again, we had some really large values on there, so we didn't necessarily mark anything on our y-axis. All right, our last one. Again, it's not factored, so we're going to go ahead and have to factor this. We're going to do C over D. We do notice that the leading coefficient is 1, so C over D is just going to be C. 24, of course, has a lot of factors. So that's our C over D. Let's start trying these. So our coefficients are 1, -3, -6, 28, and -24. Let's try 1. All right, so not 1, but there is the point 1, -4. That's kind of helpful. Let's try 2. All right, so that worked. So we have to the 4th power, so this one's down to cubed. So now we have 1, -1, -8, and 12. We'll go ahead and 2 worked, so we know that it could work again, so we're going to go ahead and try that. Bring down the 1. Oh, it does work again. So 2 times -6 is -12 plus 12 is 0. And so now we are down to just x squared plus x minus 6. Also note, like, we have 2 worked, so this is x minus 2, and this 2 worked. So we have 2 factors of x minus 2 so far. This is f of x, and so this equals, let's see if we can factor some more. And this last trinomial, we need an x and an x, and it looks like a +3 and a -2 is going to give it to us. So actually, this one is x minus 2 cubed times x plus 3, which means our zeros are at 2, multiplicity 3, and -3. So -3 and 2. Our y-intercept, I'm actually not going to graph a lot of extra points here because we do have our y-intercept, which is -24. Let's count by 4s, so 4, 8, 12, 16, 20. That's -24. That's our y-intercept. This is multiplicity 3, so it is going to cross through, but I do want to show you that it doesn't go straight through, it kind of curves a little bit there. So our end behavior, or our tails, this is even and positive, so they're both tails are going to go up. So the right's going to be at both, let's just put both up. There's not any special symmetry here. It's not an even or odd function. So what we're going to do here, we're going to come down. We come to -3, and it passes right through there. We're going to hit -24. It might go down lower and then come back up and hit -24. We're not exactly sure, but let me show you what happens at this multiplicity 3 here. It comes up, and it usually does a little bit of a turn like this, and then comes up like that. So if it's multiplicity 3 or 5 or 7, something larger than 1, it usually passes through like that. So there is the graph of